When we look at multiplying polynomials, kind of to start with binomials, we're going to use this idea called this box method, which is also known as the area model. So let's start out with two binomials. So I have a plus b times c plus d. I'm going to write a plus b on this top of the columns, and then c plus d are on the rows. And anytime I fill in a box, I multiply the two values, the two dimensions that make that up. So that's going to be a times c here, b times c, a times d, and then b times d. By doing this, I've made sure that I've multiplied every value in each binomial by the values in the other binomial. So I went a times c, which were the first terms, a times d, which was first and last, b times c, which are those inside ones, and then b times d. There's other methods we see, FOIL is sometimes thrown around, but this way makes sure we're organized and all the values do get solved. So let's look at how this works. I have x plus 3 and x plus 1. I'm going to draw my box. X plus 3, x plus 1. X times x is x squared. X times 3 is 3x. X times 1 is x. 3 times 1 is 3. I filled in the four boxes. I now look for like terms, which is x and 3x. So when I write it out, I go x squared. X plus 3x is 4x plus 3. So now I could say that x plus 3 times x plus 1 is x squared plus 4x plus 3. Our next one, x minus 6 and x plus 6. Again, I draw the box. It doesn't matter which one I put where, but I usually put, if I have a negative one, I try to put that on the top just so I don't forget the negative. It's really easy to lose it down here. So I got x times x is x squared minus 6x, 6x, and minus 36. If I look, I have like terms here, so it's going to be x squared. 6x minus 6x is actually 0, so I'm not going to write that. My last term is then negative 36. So this is one where those middle terms became a 0, so I'm left with just a binomial. This last one here on the right, x plus 2 squared. What we're not going to do is write x squared plus 4. That is mixing up what we did with exponents and solving rules with multiplication instead of dealing with binomials, which we're looking at. So what we first need to do, a good thing is to split this into two terms, x plus 2 and x plus 2. So I'm going to write x plus 2, x plus 2. X times x, x squared. Then we got 2x, 2x, and 4. We have like terms. So we go x squared, 2x and 2x is 4x, plus 4 is our solution. Now, this is the process that we use. What we're going to look now is if we can expand it, use it on bigger values, bigger polynomials, and what if we had multiple polynomials. So let's come down and look at x squared plus 2 times this trinomial. Before it was a 2 by 2 box, so now I'm going to make it a 3 by 2. So when I write x plus 3, or sorry, x to the third, 2x and 6 on the top, each gets a column, and x squared plus 2 each get a row. So the first box, it goes back to our critical rules that we had for the product rule. X squared times x to the third gives us x to the fifth. Next to that, we're going to go 2x to the third, and then 6x squared. What we've really done there is we've multiplied x squared to each of the terms in that trinomial. Next row is multiplying 2 to all of those terms. 2x to the third, 4x, and 12. Now, if we look at like terms, I have like terms right here. They're both x to the third, but these are not, and that's fine. And usually we see like terms in as diagonals, but they're not guaranteed. We'll still just write it out with our solution. So I have x to the fifth is our lead term. X to the third and x to the third, we get 4x to the third. 6x squared is next, then 4x, and then last 12. Now, what if we have 3 binomials? What we're going to do is just do 2 at a time, get an answer, and then multiply that one to the third. Multiply that answer to the third one. So first off, let's go x plus 2 and x minus 1. So we got x squared 2x, negative x, and negative 2. This gives me an answer of x squared, 2x and negative 1 is a positive x minus 2. That's what I got from here. I bring down x plus 3. So now I'm going to do x squared plus x minus 2 times x plus 3. We get x to the third, x squared, negative 2x, 3x squared, 3x, and negative 6. We have like terms in this diagonal as well as the other. So we write it out. We're going to go x to the third. 3x squared and an x squared is 4x squared. 3x minus 2x is an x, and then minus 6. So let's look at some other ones that we have. X plus 3 squared. We're not going to automatically put the squared on both terms. We're going to split this to x plus 3 and x plus 3. So we have x times x, x squared. Then we go 3x, 3x, and 9. Like terms with the 3 x's, so our answer is going to be x squared plus 6x plus 9. 3k minus 8. Again, write it twice. Then we use the box. We multiply, we get 9k squared minus 24k. Minus 24k, and a positive 64. When we combine the terms, we have 9k squared as our lead term, negative 24 and negative 24 is negative 48, and then a plus 64 at the end. Next, we've kind of changed the variables that we have in the exponents. So we're going to go 2v to the third plus 4, and v squared plus 7v. Be careful with our exponent rules here. V squared and 2v to the third is 2v to the fifth. Then I have 4v squared. Next, 14v to the fourth and 14v. Going from largest to smallest in the exponent, we're going to go 2v to the fifth plus 14v to the fourth plus 4v squared plus 14v. Next one is a trinomial times a binomial. X plus 3 and x squared plus 2x plus 1. We have x to the third, 2x squared and x, 3x squared, 6x, and 3. Our first term is x to the third. 3 and 2 gives us 5x squareds. 6 and 1 gives us 7x. And then the 3 on the end. Next, I have to find the area of the shaded region, also known as the square donut. So we're going to find the area of the big square, and we're going to subtract the area of the little square, and that's going to give us the area of the donut. Well, the area of a square is going to be x plus 6 squared. Area of the little one is x minus 2 squared. But again, we're not going to write this as x squared plus 36, because that breaks the rules that we have. So instead, I'm going to write this as x plus 6 and x plus 6. We have x squared, 6x, 6x, and 36. So this becomes x squared plus 12x plus 36. For the other one, with x minus 2, we got x squared minus 2x, minus 2x, and positive 4. So we're subtracting x squared minus 4x plus 4 from our larger area. So x squared minus x squared is just 0x squared. 12x minus negative 4, we should just bring down the negative here, change the signs. 12x plus 4x is 16x, and then 36 minus 4 is plus 32. So the area of that region turns out to be 16 x plus 32. We found that multiplying for both of them and then subtracting to find the difference with like terms. The last one we have is we have 3 binomials. Now I'm going to pick these two to start with. I'm going to do x plus 2 and x minus 5, just because they look kind of like the easier ones. So I have x squared, 2x, negative 5x, and negative 10. So when I bring that down, that is my trinomial. Bring down 2x plus 1, so I'm going to multiply that to then finish the problem. So we have 2x to the third minus 6x squared minus 20x, x squared minus 3x minus 10. Our like terms give us 2x to the third. Negative 6 and 1 gives us negative 5x squared. Negative 20 and negative 3 is negative 23x, and then a negative 10 at the end.